I'm going to demonstrate how to take a slow-mo video and analyze it now. A slow-mo video just means that your camera, rather than taking 30 frames per second for a regular motion video, you can actually select a higher frame rate. And so, for example, the current iPhone 5 and 6, they have slow-mo rates, a maximum speed of 240 frames per second. So if you take 240 divided by 30, the normal speed, it's actually 8 times slower. So it slows things down by a factor of 8. But it means also that you get 8 times as much data. Because the video frames are being taken so quickly at 240 frames each second, there's less time for the light to enter the camera, and so you really have to have a very brightly lit situation to get good video out of a slow-mo video. So given that, let me show you how to do this. So I'm going to insert movie, and I'm going to do Lucy's basketball toss at 240 frames per second. And what we'll do is we'll spread this to full size so we can get a good look at this. Alright, like before, we're going to set up a ruler to set up a scale for this. And you'll notice Aaron is holding this ruler in the same plane of motion this ball is moving in. And so I go from the bottom of the ruler, I'm clicking and holding to do this, and to the top of the ruler, and that is actually 1 meter exactly. Alright, so we've established a scale for this video. Now I'm going to set up our axes, our XY axes. We're going to put it on the floor here. I'm just going to leave it on the floor because I know this is the floor right here. If I had to do it over the basketball, I would have a little bit of issue because I can't tell exactly where the floor is in this case. Because by our knee, it's way over here, but the basketball, you'll notice it's out in front of it here. We don't really care about our X dimension in any case. We only care about the Y, so I don't really care if this is shifted off to the left or the right. Now we need to do some setup. So what we're going to do is we're going to select the movie options, and we always click off on this, the first frame of the video where I start collecting my data points. I want that to be 0. Alright, now we have to override the frame rate. It's going to assume that any video you put in is automatically at 30 frames per second, which is the standard for video. So we're going to click on this, and we're actually going to set this up for 240 frames per second. And you need to be careful about that as well, because your cameras can actually be set at different frame rates. But the highest currently for an iPhone 5 or 6 is 240 frames per second. When we take 240 frames per second, we're getting 8 times as much data. We might not use all that data, and so we might want to go back, because you can actually skip if there's too much data for you and you want to maybe skip every other time frame. You can actually put a 2 here, and that'll skip every other time point. And if that's too much data, you can skip every 3rd, 4th, or 5th, or something like that to get the exact amount of data you would like. Like I said, for our purposes, for this lab, it'd be nice to have at least 20, maybe 20 to 30 data points. And so you'd want to pick a number that works out for you in that case. But we'll go back to that if we need to change it. Let's just try this out. I'm going to play my video to move it to the spot where she is going to release the ball. All right, and here we went to slow-mo mode. Alright, and I think what I'll do is maybe I'll capture her whole downward motion too, and we'll see how she's holding this ball. So I'm going to move this back a little bit here. Alright, so I think I'm going to start right from about here where she starts moving down. Now you got to decide at what point on the basketball should I collect my data. You could say, all right, I'm going to use this middle line here, but the ball may rotate, so that line may move out of your range of motion. I need to be tracking the motion of the spin rather than the motion of the ball. So what I'll do is I'm going to use the top edge of this ball. And I've already looked at this video, and the top edge seems to have a nice clear outline the whole way through. And I think we want to skip a few frames at a time. I'm clicking on these two forward and reverse. This is moving me frame by frame. So I'm going to choose maybe... If I choose 8 frames to skip every 8th frame, I'm basically back to a 30 frame per second situation. In fact, I think I'm going to do that. I think I'm going to pick out 8, which is going to give us 30 frame. It'll pick out the pictures if we're on a 30 frame per second. But you'll see on the slow-mo video, you get a very clear picture of what's happening compared to a regular mo video, as I like to call it. I'm going to skip every 8th frame, and it'll automatically take care of all the math for me in the background, all the plotting. And now I'm going to go ahead and start adding points at the top of the ball here. So I'm just going to try to hit the top of the ball each time as it moves. All right, so she's moving down a little bit here. Okay, now we're moving up. And you notice the background we selected here is a nice color contrast. It's a little bit hard to see the color contrast against her uniform that she's wearing, which is her Halloween costume. But against this board and the wall, it's very easy to see the object. You have to take that into account when you're planning out your data collection activity. A little bit harder to see up here, so we could have maybe put some white paper on the background up here to make it easier to see, to create a very high contrast background. And once again, you can see white against a dark color makes a world of difference in being able to track the edge of this object. So you really want to think carefully about picking out a background that's very easy for you to collect data against. Otherwise, your data gets muddled, and you won't get very good data. It'll put a little error in your data you can avoid. So just be careful when you do this. So it's easy to do against the white, but now when we get back down to the muddled colors, easier to do it against this darker background too. It's just when you get into this transition zones, like against her pants. We'll see how it works. And here we are, just about ready to hit the ground. Now it's bouncing up. We'll capture this bounce too. And we can measure Lucy's reaction time here. Coming back down, still in free fall right now, with the exception point where it bounced in the air. And now Lucy's touching it, and we'll take this as her last point. All right, and that's our video. All right, I'm going to click on this background here, bring it forward, and here's Lucy moving it down. Here she is accelerating it upward. At some point here, she lets it go, and it's free falling. It goes up, comes back down, it bounces on the floor, comes back up again, free fall again, bounces on the, and she catches it over here. We don't really care about this X motion, and I'm actually going to right-click on the graph options, and I'm going to turn off the X. We don't really care about the X dimension, only the Y dimension for here. Done. So there's our Y-axis. And the other thing I'd like to do is I'd like to add another graph here. Insert graph. That's some interesting data. That looks nice. It automatically assumed I wanted velocity data. All right, and so we got position, we got velocity, and that's some good looking data. So we have position and velocity graphs in the Y direction for the object as it moves through the air. And from this point, you can go through. Let me just demonstrate really quickly again. What should we take off this top graph? We really want to see if we have a parabolic fit here. So I can actually do a curve fit, which is this function right here. Let me select some data first. It looks like from here to here we're in free fall where we're linear. So I'm going to start maybe from about right here. I want to go from a little past 1 second to a little bit after, what about just about to 2.2 seconds. Let me try this again here. So I'm looking at my bottom graph to do this. I'm trying to line this up with the linear portion of this function. So now I'm going to hit my curve fit. And once again, from our theory, we expect this, if it's constant acceleration, this should be a quadratic function. I'm going to use a time offset. I'm going to establish a time offset. It's going to use a 0 time as whatever my start time is here. I'm going to do the fit for that. Those are my coefficients. I'll hit OK. You can actually create a calculated column if you want. It'll create a column of your data, so you can match up your measured data versus your model data if you'd like. I'm not going to do that for this, but you could if you wanted to for whatever reason. And there's my regression statistics that you need to interpret and tell me what those mean. Same thing down here. We'd expect this area should be linear. Let's just see how well a line fits through this. So I'm going to do a line fit through here. There's my line of best fit. I'll move this out of the way so you can still see the graph. And you'll notice we're getting a slope of negative 10 meters per negative 10.15 meters per second squared. If we double this, we get negative 10.13 meters per second squared, as compared to negative 9.8 meters per second squared. So this is within about 3% or so of our actual number. So can't complain about that. And then you could do percent errors, things like that. You'd have to explain what each one of these coefficients mean, explain why we can do this, explain why this is linear, and explain what these coefficients mean, and do a little bit of write-up on it.